Okay, well, good morning. Thank you, Shayna, for that kind introduction. Thank you to all of you for being here, both in person and online. It is a privilege, truly, to share with you information on a topic that is near and dear to my heart, natural history studies. Here we go. Okay, so I think it's important to start with the question, what is a natural history study? And in a quiz format, I have an A, B, C, D option. So is a natural history study a study that aims to learn if treatment or medication improves or treats a specific condition or disease? Is it B, a study that aims to learn if research mice can live long, healthy lives when given natural health aids or supplements? Is it C, a study that aims to learn how diseases or disorders develop over time? Or is it D, a study that aims to learn if AI can predict our behaviors or outcomes in response to a specific trigger? Show of hands for anyone who thinks a natural history study is A, a study that aims to learn if a treatment or medication can improve or treat a specific condition. How about B, research mice? Anyone think C? Oh, you guys are really smart. Or D, AI, which just, had to be an option. So the right answer is C. If you didn't get it, that's okay. Hopefully you will learn more throughout this presentation. Before we talk more about what natural history studies are, I actually think it's really important to start with the why. Why are they important? Why are you asked to participate in natural history studies if you're someone with FTD or at risk of developing FTD? Because we're in Colorado, we're going to use this mountain metaphor to talk about the why. So the goal is to climb to the top of the mountain, to make it there. The goal is a treatment for FTD. How do we get there? How do the mountain climbers get there? We get there with clinical trials, research studies that are testing treatments, testing medications. And the trials along the way all lead us to the eventual top of the mountain, the FTD treatments that we are so desperately hoping for. But what actually supports all of these trials, these mountain climbers on their journeys, are natural history studies. How do they do that? Data from natural history studies is actually very important for clinical trials, specifically clinical trial design. Data from natural history studies helps with inclusion and exclusion criteria. What is that? That's the criteria that you have to meet to be eligible to participate in that study. Whether it's trying to determine if you have mild, moderate, or severe disease based on a questionnaire or a series of questionnaires, natural history studies have created the knowledge base to be able to make the determination of what score or what range of scores might indicate a mild or moderate disease that might mean you are eligible for a clinical trial. In the case of a recent FTD clinical trial, one of the inclusion and exclusion criteria was actually a level of a protein in your blood called neurofilament. Data from natural history studies helped that pharmaceutical company determine what range of neurofilament light chain would be most appropriate for inclusion in their research study. Data from natural history studies is also really important in trial design when determining endpoints. So how do you know if your clinical trial is working? You have to have endpoints, whether that is a score on a neuropsychological exam, whether it's a brain analysis like brain volume detection, or something different. Natural history studies have helped create the knowledge base that pharmaceutical companies use to determine what a successful trial will be determined on based on these endpoints. You can see that simply in the graph, right? Linear lines are easy to think about, so that's why I'm using them here. But if you have an FTD like biomarker or symptom on your y-axis, maybe it's performance on one of those memory and thinking tests or one of the neuropsychological tests. In an asymptomatic phase, that's fairly stable. And then as you dip into symptoms, your performance might decrease as you near that symptomatic phase. Natural history studies create these trend lines such that as you're designing your trial, you might hypothetically say, if we intervene halfway on that decline with a clinical trial treatment, we might change the slope of that line. Natural history studies help you know if the slope change of that line is enough to know if your treatment is working. Similarly, natural history studies can help us learn more about what is that elbow trigger point between the flat, stable line of an asymptomatic symptom onset and then onset of disease. And maybe right at that elbow, we can intervene with a drug or a treatment, and we can maintain sort of an asymptomatic stage. And lastly, well, it has not yet been done in the FTD space. Data from natural history studies could also be used as a control arm in some clinical trials. Now that we've talked a little bit about the why, let's talk again about the what. What is a natural history study? Definitions are helpful, I think, to orient us. Quite simply, a natural history study or an observational study is a research study that monitors people in normal settings over time. Researchers gather information from people and compare changes over time. If you're thinking about an FTD natural history study, it would be a study that collects information about the natural history of FTD in the absence of an intervention, from disease onset or even earlier to either its resolution or eventual death. Natural history studies are often referred to as observational studies or longitudinal studies. The key with natural history studies is observation over time. Often natural history studies and clinical trials kind of get grouped and looped together in a way when people want to participate in research. So it's important to tease out the differences between the two. Again, a natural history study collects information about the natural progression of a disease in the absence of an intervention, whereas a clinical trial is different in the fact that it is a research study that tests a medical, surgical, or behavioral intervention in people. These trials are primarily used to make sure that this new treatment or prevention is safe and effective. So the difference, a natural history study is an observation over time in the absence of an intervention, and a clinical trial is a research study that tests if an intervention, like a drug, is safe and effective. Now that you know what it is, if you were in a natural research study for FTD, what might you be asked to do? Some common procedures in natural history studies are blood collection, memory and thinking tests, so neuropsychological exams, an exam by a neurologist or a similarly trained clinician, a lumbar puncture, which is used to collect cerebral spinal fluid, questionnaires about your mood or your behavior or your actions, some speech assessments, motor assessments, maybe some imaging exams, so an MRI or a PET scan, and then sometimes brain or tissue donation. You might be thinking to yourself, I think I've participated in one of these studies, and you probably have. And if you haven't or you're not sure, you should go to the FTD Disorders Registry page. They have a wonderful page called Find a Study, and it's a whole list of research studies you can participate in. This is a screenshot from a few weeks ago of their natural history or observational studies that are happening right now in FTD that you could participate in. Back to the why. Clinical trials are important. We all want a treatment, but there are a few other reasons why natural history studies are important. We already know the first bullet point here, but natural history studies also help us because they collect data that will help us diagnose FTD more accurately. They collect data that will help understand disease progression, and they also collect data that will help us understand risk factors for FTD. So how do they help us with diagnosis? Due to biomarkers. Natural history studies collect biomarkers. I know I've already used the term in my talk earlier. I'm sure it's a term you've heard before. I think it's often confusing. It sounds foreign. What is a biomarker? Very simply, a biomarker is something that can be measured to determine if the score or value or quantity is normal or abnormal. If it's abnormal, that may be due to the presence of a disease. So what types of biomarkers are collected? Now that we know the definition, blood, right? Blood is sort of the first thing you might think of. We know that levels of proteins in your blood may change due to the presence of FTD, a stroke, Alzheimer's disease, or another brain disorder. Natural history studies have helped provide the data that we need to refine blood tests to not only diagnose FTD, but other brain disorders like Alzheimer's disease. Importantly, we don't yet have a blood test that can definitively diagnose FTD, so there's still work to be done. Another biomarker that is collected is cerebral spinal fluid. That's the fluid that surrounds your brain, and it's in your spinal cord. It's collected through a procedure called a lumbar puncture or spinal tap. Cerebral spinal fluid, because it's the fluid that surrounds your brain, is rich in information about what is truly happening in your brain. We know that we can measure proteins like beta amyloid or tau or phosphorylated tau, right? All three of those are very important in Alzheimer's disease. And we can also measure neurofilament light chain, or NFL. Data collected through natural history studies has helped us determine that NFL is a good FTD biomarker. And this is a true win for natural history studies, for science, and for those impacted by FTD. So let's talk a little bit more about NFL. Neurofilament light chain exists because when the axon portion of a neuron degenerates, it releases neurofilament. Neurofilament then filters from your brain into your CSF, right, the fluid that surrounds your brain, and eventually ends in your blood. There are different sizes, essentially, of these neurofilaments, and one of the sizes is the light chain. This protein, neurofilament light chain, we know correlates to having a diagnosis, the amount of having neurofilament light chain correlates to having a diagnosis of FTD, FTD-ALS, or ALS. Importantly, data collected through the ALLFTD natural history study, an ALLFTD natural history study is the largest FTD natural history study in North America. Data collected from that study found that neurofilament light chain levels were elevated in different FTD disorders. It might then be useful for differential diagnosis. The study also found that NFL levels were elevated in those with genetic FTD mutations who were asymptomatic. That elevation might be an indicator of potential disease onset in a few years, an important early biomarker. And the study also found that NFL levels were elevated in relation to disease severity. So as the disease progressed, these levels increased. Importantly, because of work done through the natural history studies around the world, the Foundation for the National Institutes of Health, or the FNIH, announced that in last May, the US Food and Drug Administration accepted their letter to qualify NFL as a biomarker for the early detection of FTD. It sounds like a lot of words, but this is a big deal. This is exciting. Qualifying NFL as a biomarker for the early detection of FTD will be so important and helpful in drug development and clinical trials. Switching gears a little after talking about NFL, back to our biomarkers. So in addition to blood and CSF, some biomarkers that might be collected during natural history studies might be imaging measures. You might have an MRI or a few PET scans. Data from natural history studies has helped scientists determine what level of brain atrophy on an MRI is normal for your age and your sex. And if it's abnormal, is that due to the presence of a neurodegenerative disease? Natural history studies have also contributed data to help us determine what level of accumulation of abnormal proteins in your brain might be normal for your age or sex, those PET scan analyses. In addition to imaging and biofluids, there's also neuropsychological tests. Some of you may think of these as the dreaded memory and thinking tests. Yes, they are not fun, I can attest, but they're important. They're so important. They help us measure language. We know if language is impaired because they ask questions about naming or grammar and comprehension. They can also measure attention and executive functioning or see if visual spatial capabilities are impaired. They're very helpful in aiding in the diagnosis of different FTLD syndromes. In the interest of time, I can't go through all of the biomarkers and all of the ways that different procedures contribute to our understanding of FTD, but there are a few others you should be aware of. The questionnaires and rating scales asking about your mood or your behaviors or your actions are important biomarkers. Motor assessments provide important biomarker understanding, as do speech assessments. So we know that right now biomarkers help us rule in or rule out different diagnoses. And often, and I think for a long time, multiple biomarkers will be needed to most accurately diagnose. As we continue to collect biomarkers through natural history studies, we'll be able to better refine not only our understanding of biomarkers that might indicate FTD onset, but also progression. How do we, though, use data from natural history studies to help us understand progression? If you remember our definitions, natural history studies are an observation over time. Those changes over time are monitored. And because biomarkers are collected over time, we can use that data to start to create a more comprehensive understanding of how different biomarkers change as disease onset approaches, at disease onset, and then as FTD progresses. Data from natural history studies helps us create graphic images like you see on this screen, where in the asymptomatic phase, we know clinical status like your performance on those neuropsychological tests and your brain volume are sort of at a high level. And then as onset approaches, maybe your brain volume slightly starts to decrease or your performance on those neuropsych measures gets a little bit wiggly. We also know, because of data collected from natural history studies, that proteins in your brain, in your blood, like inflammation markers and neurofilament light chain, start at low levels. And then as symptoms approach or onset approaches, those levels increase. And so we can create a graphic understanding in this way of what we know changes before symptoms, at initial symptoms, and then as the disease progresses. Multiple visits are important. Here's my plea. If you are someone in a natural history study who is late to their next follow-up visit, please call your study team. Now, we really, really need multiple visits to build those graphic images like you see to complete our full understanding of how things change over time. One way that we create those graphic images like you saw is MRIs. If you do an MRI at every visit, we have the technology to zone in on a cube-sized portion of your brain, like in this little cartoon here. And at each time point, we can see how the volume in that specific region may change. And then we can use that to create these curves. We can also take it one step further and create models that really model how the disease may progress. These graphs are pretty, but might be a little confusing, so let me orient you. The x-axis has negative numbers up to positive. Time point 0 is the model for disease onset, or when you might show up in the clinic and your neuropsych measures might be such that you now would get a diagnosis of FTD. Because of data collected through the ALLFTD natural history study and a similar study happening in Europe called GenFI, we are able to create models. And these are 3 models that we created using data collected. It's for the 3 main genetic mutations known to cause FTD. One of the benefits of studying familial FTD is we can capture the changes that happen before symptom onset because we have individuals participate in natural history studies who are from families with known or likely genetic mutations who contribute their data every year, so we can build models like this. You'll notice the black line is called it's a bunch of acronyms, but it's basically a gold standard measure in the clinic of disease severity. The orangish line is a neuropsych measure that seems to be sensitive. You'll notice it's different in the 3 familial mutations. That's because we have found that there seem to be tests that are more sensitive to different mutation types. MRI volume changes is, I think, in green. It's a little hard to see up here, but I think it's green. And then lastly is the NFL measures in purple. So you can see how they all change. And in some cases, like in the C9 graph on the left, some of those early indicators change many years before that time point 0. These disease progression models are important as we think about clinical trial design, and might also help us intervene at sort of that elbow that we talked about at the beginning, where we might be able to intervene at a time point where you're mostly asymptomatic. Sadly, in the interest of time, we can't go into too much detail, but natural history studies are also really helpful for helping us learn more about risk factors and FTD. If you're not aware, a risk factor is something that increases your risk or susceptibility. We can do that using data collected through natural history studies because we collect data that ask questions about your lifestyle, your general health history, your current health history, and your occupation or environmental factors. If you scan the QR code, you can get access to some information on risk factors in FTD that I do not have time to present today. And lastly, just a little hope. FTD is hard and it impacts many of us and it impacts people all over the world. And as such, there is a global consortium of investigators and scientists and researchers working to learn more about FTD. The FTD Prevention Initiative was established in 2014 by Professors Jonathan Rohr and Adam Boxers. And the key goals of this group are to create uniform standards for the conduct of clinical trials in familial FTD, to create an international database of FTD research participants gathered from these natural history studies, and to promote responsible data sharing between these observational studies and clinical trial companies. You can see this global map here with some logos and of the different groups within this initiative. And with that, in the interest of time, I will just say thank you to my collaborators and support, both at Mayo Clinic and ALLFTD. I'm happy to answer any questions after this session that you may have about natural history studies or FTD. The most important thing is just to say thank you to all of you who have ever participated in a natural history study. Thank you to those of you who have participated in Artful or Lefties or now ALLFTD. We couldn't do any of this work without you and your families and those that support you. And with that, I will turn it over to my international colleagues who will share with you via video information about their programs. Thank you.
Hello everyone, my name is Elisa Rezende. I'm a neurologist from Brazil, and I coordinate a Red Lab at our clinic in Belo Horizonte, Brazil. In our clinic, we combine seeing patients at clinic with research because unfortunately we don't have resources to separate research from clinical work. So in our study, we recruited participants from our clinic that we will see in our video. And also we're going to see some of our research members showing how they assess patients and why they study the frontotemporal dementia team and how important is it to study this disease for the world.
Hi, my name is Luciano Mariano. I'm a neuropsychologist with a PhD in neuroscience. I have been working with frontotemporal dementia over the last 12 years, and we were initially interested in cognitions, how executive function, social cognition can improve the differential diagnosis, but also behavior such as apathy and impulsivity, because those markers are quite important for us to understand and treat these patients. And later on, we have included neuroimaging and some other biomarkers in helping the differential diagnosis and rightful treatment. And now we are also implementing some patient and public involvement. So we are listening to the patients themselves and their families in order to bring a different and better perspective into our research focus.
Hello, my name is Leonardo de Souza. I am a clinical neurologist at the Federal University of Minas Gerais at Belo Horizonte, Brazil. We conduct research on frontotemporal dementia, and our main focus is to establish the clinical differentiation between frontotemporal dementia and other diseases such as Alzheimer's disease and primary psychiatric disorders. We use clinical markers such as structural and functional neuroimaging, and also biological markers and neuropsychological tools, including social cognition tests, to differentiate frontotemporal dementia from other diseases. We are also interested in the overlapping syndromes with frontotemporal dementia, such as progressive supranuclear palsy and also amyotrophic lateral sclerosis. The results of our research can help clinicians to guide the diagnostic framework of frontotemporal dementia. Thank you.
Hi, my name is Thais Machado. I'm a speech and language pathologist and professor. I've been working in this outpatient clinic for 17 years, mainly with patients and families in a multimodal program of rehabilitation for PPA.
Hello, my name is Bárbara, and I'm an occupational therapist. I have been working with people with dementia and their families for 17 years. Here at the clinic, we provide care for individuals with FTD by conducting functional assessments and collaborating with our multidisciplinary team to support diagnosis and case management. We also develop personalized strategies to enhance patient participation in daily activities. In addition, we offer support groups for family caregivers, as many of our patients have a low level of education and limited access to information. These groups provide guidance on managing behavioral symptoms, promoting engagement in meaningful activities, and addressing caregiver well-being, as they often face significant challenges as the illness progresses. Our main goal is to support caregivers while fostering meaningful engagement in daily life for individuals with FTD.
What attracted me to work with individuals affected by frontotemporal dementia is a blend of my psychiatric background and my desire to support the elderly. Among the several forms of dementia, FTD presents a unique challenge, particularly because it's often the most difficult to differentiate from psychiatric disorder. This intricate relationship between neuropsychiatric symptoms and FTD captivated my interest and inspired me to dive deeply into this field.
Hello, I'm Paulo Caramelli. I'm a neurologist, professor at the Faculty of Medicine of the Federal University of Minas Gerais, where I also coordinate the Behavioral and Cognitive Neurology Unit. I'm here to show you our outpatient clinic. Here we have all the consultation rooms where our multidisciplinary team sees patients every week. Every Friday, we see around 25 patients with cognitive impairment and dementia. The multidisciplinary team is composed by physicians, neurologists, psychiatrists, geriatricians, and also by neuropsychologists, occupational therapists, and speech pathologists. The patients are evaluated by the multidisciplinary team and followed over time. Here is one of the consulting rooms we have in our facility.
If you want to join our research group or if you want to become a participant in our study, you can reach out to us at our website, cogneuro.org. We are going to put the website here in the video so we can click on it, and you can, there is an English version, you can contact us directly. And we also are on X, so cogneuro.ufmg.org. You can contact us as well at Twitter. Thank you so much for listening to us. Bye-bye.
My name is Bridget Ryan. I'm a senior lecturer and neuroscientist at the University of Auckland, and I lead FTD GENS, which is the New Zealand Genetic Frontotemporal Dementia Study. We work within the Centre for Brain Research at the University of Auckland, which is a research institute involving clinical and academic neuroscientists from across the university. So we're really lucky to be working with an amazingly generous single family who have a tau mutation that causes genetic frontotemporal dementia. The grandmother in this family generously donated her brain to the Neurological Foundation New Zealand Human Brain Bank when she passed away. And that triggered the family to want to be involved in research. So this project was actually co-developed alongside the family over a long period of time. We're doing a wide range of testing in pre-symptomatic members of this family, so many years before they're expected to develop the symptoms of frontotemporal dementia. We're taking a number of measures that are consistent with international cohorts so that we can compare our data, including brain imaging, blood biomarkers, and neuropsychology. We're also looking at a number of more novel measures, including auditory and vestibular and retinal changes, and we have a particular focus on microRNAs as blood biomarkers. So we believe that the most important approach to combating dementia is early detection. So our study is a longitudinal study which is all focused on identifying the very earliest changes that are happening in genetic frontotemporal dementia. And the rationale behind this is that if we could intervene really early in the disease process, we'll have the best chance at preventing or delaying onset of FTD. So in addition to FTD genes, which is our longitudinal study of a single family with genetic FTD, we are also interested in other avenues of FTD research here at the University of Auckland. One of these approaches is that we're doing some pioneering research looking at the human brain tissue from New Zealanders who have had frontotemporal dementia. And secondly, we're doing some really important work looking at the demographics and epidemiology of FTD in New Zealand. I was drawn to working in the research field of FTD because my grandma was diagnosed with dementia. And although it was really difficult to see her decline, it inspired me to want to do research in the general area of dementia. Later in my career, when I was introduced to this family who have genetic frontotemporal dementia, it really brought home to me how different their experience was, particularly because they were dealing with dementia at an earlier age. And from that time on, I've focused my career on FTD. I'm optimistic about the future of FTD treatment because I think that the shift in focus to prevention and identifying the really early changes that are happening in the brain is a really positive step forward for the field. I'm also really optimistic because of the international collaborations that are happening now with relatively rare diseases such as FTD. It's so important that we bring together research participants and clinical trial participants from across the world to advance research. To learn more about our research, you can visit our website at auckland.ac.nz/CBR.
Hi, my name is Dr. Simon Ducharme. I'm a neuropsychiatrist working in Montreal, Canada, in a hospital system affiliated with McGill University. At hospitals, one is called the Douglas Institute, and the other one is the Montreal Neurological Institute. So GENFI is a very important study. It's what we call an observational cohort of patients with genetic FTD. So what we do in that study, it's an international collaboration that is led by Dr. Rohrer at UCL in London, but involves many sites in Europe, Canada, and now branching across the world, in which we follow periodically people that are parts of family where we know that they might have one of the few genetic mutations that causes FTD. So we're talking about mutations like expansion in C9orf72, progranulin mutation, MAPT. So all our participants either have the disease or are related first degree to someone that has one of these genetic FTD. And we follow them about every year with comprehensive testing, so clinical evaluation, brain scans, blood tests, even lumbar puncture. And the goal is to build a very good characterization of how this disease evolves over time and how this can lead to better tests to recognize it and eventually to treatments to delay or even stop it. So it's been going on for many years. It has now thousands of patients, but it is still actively recruiting. FTD has both genetic variants, like the one we study in GENFI, but the majority of cases are what we call sporadic, meaning that they don't have a hereditary cause. We're not actually sure why they developed this disease. So we do studies in GENFI and genetic, but also some studies in the sporadic one. And our group is particularly interested in improving the early diagnosis of sporadic FTD. And particularly because symptoms are very behavioral in nature, it's a hard task to differentiate it from some other psychiatric disorders like late onset depression or psychotic disorder. So we have a consortium called NIC-FTD, which is a Neuropsychiatric International Consortium that has been doing work in this. We're currently particularly focused on studying a blood test called neurofilament light chain, which goes up significantly in FTD, but less so in psychiatric disorders. So we're doing various studies to see if we could use that in clinical practice to identify patients with FTD earlier. And then all of that is leading us to clinical trials. So the ultimate goal is, yes, we want to diagnose, but we also want to treat. So there are several potential therapies that have been developed by pharmaceutical companies. And so we are part of networks that test these therapies in FTD and other degenerative disease like Alzheimer's disease. I'm very optimistic about the field of FTD. We wish that we could already have good treatments to offer, but developing this takes time. There's a lot of challenges in dementia research, and in particular in FTD. And if we look at what's happening in Alzheimer's disease, 15, 20 years ago, we developed better diagnostic tests, and now we were able to do better studies, and we're starting to see the first treatments come on the market. So I think we'll see the same thing happening in FTD. We're getting better at diagnosing it, at recognizing genetic variants. We have a better understanding of how this disease evolved, and this opens the door to therapies. So currently, there's the most optimism for the genetic variants. There are some very good candidate drugs targeting GRN mutation, C9orf, eventually MAPT mutation. So there are many potential mechanisms of action, but there's a lot of hope that we could eventually delay, stop, or even prevent some of these genetic forms. We're a little bit further away in the sporadic variants of FTD, but there's some work, particularly on some pathologies like TDP43 that causes FTD that could apply there. So it's a long process, but we're seeing movement in the diagnostic, and I think this would lead to better therapeutics. We provide clinical services in Montreal, but when we're looking at research therapies, often we can also include patients from other areas, even other countries. So we have different kind of studies. We have studies in genetic frontotemporal dementia. For example, we do a study with a company called Passage Bio in progranulin mutation. So we have information on that on our website of the clinical trial unit at the Montreal Neurological Institute. This is for disease-modifying therapies, but we're also trying to improve quality of life. And one of the problems we see in FTD is a symptom called agitation, which is patients who are restless, intrusive, can become aggressive. And so we have a clinical trial to evaluate a medication called nabilone, which works a bit like cannabis, to reduce this agitation. So we do that based at the Douglas Institute in Montreal. So people can reach us through the web pages of our institution, and I'm always available when people reach out to me by email about questions about their eligibility to studies.
Warm greetings from Nimhans, Bangalore, India. The numbers of people living with dementia are rising very rapidly in India, and we at the Cognitive Disorders Clinic at Nimhans aim to provide early diagnosis, treatment, and preventive strategies for people living with dementia. The National Institute of Mental Health and Neurosciences at Bangalore is the largest neuropsychiatry institute in India. And therefore, we see a lot of people with frontotemporal dementia consulting with us. In the background of their very complex needs, behavioral problems, language problems, overlapping sometimes with motor problems, they have very special needs, and there is an accomplished team of neurologists, psychologists, psychiatrists, social workers, speech and language therapists that work together to address these very complex needs of people living with frontotemporal dementia. The goal is to listen to patients and the caregivers, and collaboration is the cornerstone of all that we do at Nimhans, Bangalore.
When we suspect a patient with dementia to have frontotemporal dementia, after a detailed history-taking pedigree analysis and a comprehensive neurological examination, the subjects undergo a detailed diagnostic evaluation starting from MRI, PET MRI, laboratory investigations, CSF, EEG in relevant cases, and genetic testing with whole exome sequencing. With the support of psychiatrists, psychiatric social workers, psychologists, speech and language experts, physiotherapists, patients receive multidisciplinary and patient-focused treatment, which is very crucial.
With the support of Government of India, philanthropic organizations, and international partners, we bring together expertise in biomarkers, genetics, imaging, and clinical trials. Our collaborative efforts aim to translate research into clinical practice by developing impactful solutions and improving outcomes for people living with FTD.
At NIMHANS, the study of FTD is driven by a new wave of curiosity and dedication. Young researchers are at the heart of this mission with innovative approaches to understand FTD in great detail. The range of their work contributes valuable insights for a more comprehensive understanding of this disorder.
I work on frontotemporal dementia and cognitive reserve, especially with a focus on bilingualism. I primarily look at the neural mechanism underlying this protective factor.
As part of the research in the field of FTDs, we have developed the Indian Semantic Memory Test Battery, and we have also developed a culturally and linguistically valid test battery for the assessment of primary progressive aphasias and their subtypes.
So my focus is mainly on studying cortical morphometry among the genetic groups of FTD and sporadic ones, and also to understand how cognition and behavior changes longitudinally among these groups. So we are hoping we'll have a better understanding towards the diagnosis of frontotemporal dementia in the Indian context, and also unburden the families who are going through these hardships.
At the Cognitive Disorders Clinic, we recognize that every caregiver's experience is unique. By taking into account their perspectives, challenges, and intervention strategies, we strive to bridge the gap between clinic and home.
Together, we look forward with a hope towards future where early diagnosis, effective treatment, and better quality of life for people living with FTD become a reality.
Thank you. Thank you, Dr. Forsberg. Thank you to our incredible group of international researchers. I know I am the last thing standing between you and lunch, so just a couple quick logistics so you can find your lunch. In-person attendees can pick up their lunches at the pavilion. You're going to head to the main lobby and hang a left before you hit the main entrance. If you need help finding the way, use the map on page 9 of your program booklet or find an AFTD staff member with a teal lanyard. You can eat your lunch wherever you feel most comfortable. And if you requested a special lunch or you need assistance in obtaining your lunch, visit the registration table and ask for Bridget Graham. She'll help sort you out. To any healthcare providers here, don't forget about our special networking lunch in the Ponderosa room, where you'll get a chance to talk to AFTD staff and others working in the field. There are boxed lunches and other refreshments set up in the Ponderosa room for you. And again, I'd like to highlight our exhibitor tables in the Centennial Foyer and the Interlochen Foyer. If you finish your lunch early, I encourage you to stop by and say hello. The conference will resume sharply at 1:15 Mountain Time. Please enjoy your lunch, and if you're following along on Zoom, grab some lunch and join us in one of our lunch connection rooms, and we'll see you in an hour. Thank you.